and welcome to this presentation on thunderstorms. We're going to discuss climatology of thunderstorms and then work our way into the life cycle of a thunderstorm in this video. So first, the climatology. We'll start out talking about the annual distribution of thunderstorms across the United States, and also we'll look at seasonal distributions. So first off, annual, looking across the United States, this shows the frequency of thunderstorms for over a series of years. And it shows the average annual frequency of thunderstorms is highest across the Gulf states of the United States. Gulf states are Florida, Alabama, Mississippi, and then into Louisiana. It's pretty obvious the reason why. They have the warmest temperatures there during the year, most moisture in the lower layers of the atmosphere, which are conducive for the formation of thunderstorms. As you move away from the Gulf Coast, you can see that the frequency decreases until you get to California, the Intermountain West. Out in California, the frequency drops off significantly, and the same thing as you move through the New England states. This is the seasonal frequency of thunderstorms, the annual frequency. This is January, and you can see that the colored area shows the highest frequency of thunderstorms in January. Occurs anywhere from Texas through Florida and then up along the East Coast a little bit to North Carolina. And it makes inroads into the central part of the United States, at least as far as Oklahoma, Missouri, southern Illinois, and Indiana. This is April, and you can see that highest frequency of thunderstorms during April occurs in the southern plains, the Midwest United States. I guess you can call that the Mississippi River area. Specifically, it's centered right on Missouri, but branches out and moves away from that. And you can see that it goes into Illinois, Oklahoma, Kentucky, Tennessee, Kansas, all the way down to Texas and Alabama. So that's your highest frequency. As you move away from that, the frequency decreases. This is July. July is prime thunderstorm season, especially along the Gulf Coast. That's when you start to see sea breezes kick up quite a few thunderstorms. So that's where you see the red, the highest frequency. Also, you can see that a yellow area extends from New Mexico and Arizona across Colorado and then up into Wyoming and Nebraska. And what that's showing is thunderstorm formation over the mountains. After the thunderstorms form over the mountains, they move off into the plains, the high plains. And that's where you see a great higher frequency of thunderstorms. So the mountains are kicking off the storms. Also, this is probably the peak thunderstorm month for North Dakota. And then moving back into October, you can see that the thunderstorm frequency decreases, but it's highest anywhere from Texas, Oklahoma, all the way up through Missouri. Here is a study of the time of day at which lightning strikes occur. Looking at a climatology from 1995 till 2019. This first slide shows time period 21 Zulu until 1 Zulu, which would be anywhere from 4 o'clock in the afternoon until about 8 o'clock in the evening for the central time zone. And it shows that there is a peak in thunderstorm activity across Florida, very frequent thunderstorm activity, and then also down across Mexico into New Mexico and Colorado. Of course, the reasons that you would normally expect for this frequency of thunderstorm activity in Florida, that would be the sea breeze, and then across Colorado and also New Mexico would be a result of the mountains producing thunderstorms as elevated heat sources. As the evening progresses between 1 Zulu and 5 Zulu, which would be 8 o'clock in the evening until approximately midnight in the central time zone, you can see that there is a peak frequency in thunderstorm activity across the central plains of the United States, from Nebraska all the way down to Oklahoma. And actually that even stretches up
through the Dakotas. And the reason for that is because of the low-level jet stream that starts to get stronger in the evenings. And you notice that the peak thunderstorm activity starts to decrease across Florida and also New Mexico and Colorado. The reason for that, of course, is because the sun has set and you don't have sea breezes, nor do you have mountain or valley breezes that are producing those storms. And finally, here we see a climatology for the time period between 5 Zulu and 9 Zulu, which for the central time zone would be midnight until approximately 4 o'clock in the morning. And looking at this, you can see the peak frequency of thunderstorm activities across the Central Plains. That would be Oklahoma, Kansas, Nebraska, Iowa, and also down into Arkansas. And you can see actually it stretches up through the Dakotas and all the way down to the Gulf Coast. And the reason for this, once again, is because the low-level jet stream. So I just want to emphasize that peak thunderstorm activity for the central United States typically occurs late night, early morning hours because of the low-level jet stream. But along coastal regions and mountain regions, that's where you see peak thunderstorm activity in the afternoons. A similar climatological study was done for hail. This is for the time period 1982 to 2011, and it shows the probability of hail. And here they define hail as any hail that's bigger than 3/4 of an inch in diameter. And it shows that for this time period, for April, you are the highest frequency or more likely to see hail across, of course, Oklahoma, Arkansas, Texas, and parts of Kansas and Missouri. As the year progresses into July, you can see that the peak frequency of hail starts to move a little bit northwards towards Nebraska and also Kansas, but it stretches anywhere from the Dakotas down to Oklahoma. And then finally in September for this time period, you can see that there is a peak for hail anywhere from the Dakotas down to Oklahoma in the central United States.
And then how tall do thunderstorms go? Well, there are two factors. One is the instability of the atmosphere. So the more unstable the air, the taller the storms get. The other reason is because of the tropopause. Depending upon the time of year, the tropopause may be higher or lower. Typically, tropopause is much higher during the summer and much lower during the winter. So if thunderstorms form during the winter, they'll be short, squatty thunderstorms typically. If they form during the summertime, since the tropopause is much higher, you'll see thunderstorms that go up to 50,000 feet. So height depends a lot upon stability and the tropopause.
Next, we'll take a look at the life cycle of thunderstorms. In 1947 and 1948, the Thunderstorm Project used surplus World War II aircraft to probe into thunderstorms. They did simultaneous penetrations of thunderstorms to kind of uncover the nature of thunderstorms. And they did this in two locations. They did it down in Florida, looking at air mass thunderstorms, but also across Ohio. And there they experienced several different types of thunderstorms besides air mass. They also went through multi-cell and even perhaps supercell. They didn't have those classifications at that time. They were just flying through thunderstorms to get an idea of what was going on in a thunderstorm. The paper that came out of that is the Thunderstorm Project. Actually, it was a document that gave a very descriptive overview of what thunderstorms were all about. And if you like, you can go out to the National Weather Service at Wilmington, Ohio. Their website has the video and also has a description of the Thunderstorm Project. The Thunderstorm Project came up with a classification for the life cycle of thunderstorms. Thunderstorms go through three different stages: the cumulus, mature, and the dissipating stage.
The cumulus stage is the growing stage of a thunderstorm. This is as it starts to go up through the freezing level, which is typically anywhere from 10 to 16,000 feet during the summertime. A thunderstorm, as it grows in the cumulus stage, is known as a towering cumulus. And this is all updraft. Typically, the worst hazards that you're going to get from a towering cumulus, if you fly through these, is massive icing. You'll get severe icing, and usually it's glaze or clear ice, and also very vigorous turbulence. As you go into a thunderstorm, you're going to experience initially a downdraft and then a strong updraft in the middle of a towering cumulus cloud. However, at this stage, there's no precipitation reaching the ground, and that's what defines the cumulus stage. That's what a towering cumulus looks like at TCU. The mature stage is when precipitation reaches the ground and you have both updraft and downdraft in the thunderstorm. And this is when the thunderstorm is at its greatest intensity. And that's what a mature stage looks like. And then finally, the dissipating stage is when you have complete downdrafts, no updrafts at all, and the precipitation at the ground has decreased significantly. It's typically just light rain. And this is a thunderstorm that's immature, that's going into its dissipating phase.
This video provided you a little bit about the climatology of thunderstorms. If you want to learn more about thunderstorms, you can go to my YouTube channel where I have many more videos that deal with thunderstorms.